Hey Math 1, I've got a new video for you. It's the last set of videos for the chapter, all over 3.6. The lesson is about solving absolute value inequalities, but I thought before I do that, I probably need to explain how to do those in equation form. So, the next video is going to be all about just doing the examples on the notes. What I wanted to do first was just kind of explain, what is this absolute value and how does that procedure help us through the examples on the notes. So, first of all, these bars represent absolute value, okay? If you said the absolute value of negative 3, what that basically says is you are going to take whatever's inside here and it yields whatever distance it is from 0 on the number line. Distance from 0 on the number line. So distance is always sort of like this positive value that you measure. So when you take the absolute value of something, it basically neutralizes the inside. It makes the inside positive. So the absolute value of negative 3 is equal to positive 3 without the bars. When you take, quote, the absolute value of something, you are basically saying give me the positive amount. So it's like the absolute value of negative 3 is 3, but also the absolute value of positive 3 is 3 too. So what we're going to explore here is what happens when the inside of the absolute value is a variable and not just a whole number, okay? So taking this, what happens when we take, say, the absolute value of x? Here, let me put this not half and half between the highlighted version. Sorry about that. Let's just go all the way over here. What happens when we take the absolute value of x and we say, hey, this equals 7? Well, we have to ask ourselves this question. The absolute value of what gives me 7? Of what number gives me 7? Well, if I take the absolute value of 7, I get 7, right? But if I take the absolute value of negative 7, I also get 7. So there's actually two solutions to this equation. This equation, so all this points us to the absolute value of x equals 7 can be computed by saying set the inside equal to the positive outside, and then you find the other solution by setting the inside equal to the negative outside. And then these are our two solutions. You put an or between them, and you're done. So, if we were to get something a little bit more complex, like what's the absolute value of, here, let me erase some of this stuff over here. absolute value of 2x minus 3, and you're trying to solve the equation that equaling, say, 5. Well, we know that. We know the absolute value of positive 5 equals 5, and we know the absolute value of negative 5 equals 5, right? So what we're doing is we're saying, let this be the absolute value of negative... Sorry, I misspoke. We're going to set the stuff inside the bars equal to the stuff inside the bars. 2x minus 3 equals 5. Then we're going to set the stuff inside the bars here to the stuff inside the bars there. 2x minus 3 equals negative 5. And those will give us our two solutions. So there's the first. There's the second. If you were asked to graph it on a number line, you'd go 1, 2, 3, 4. 1, 2, 3, 4. And these would just be closed dots here and here. Because they're not inequalities, we're not going to put any shading between them. That is what it is. All right, so I think I'm going to stop the video there. I just wanted to make sure we explained the procedure of, hey, absolute value is this situation. So if we were to have like an equation, and you'll see inequalities in the next video too, where the absolute value bars are on one side, then what we need to do is set it equal to two different amounts. All right, this is kind of tricky, so it'll take a few days to figure this out. Thanks for watching.